Welcome to the final session for today. We've got a little bit of fun stuff to show you, and I would like to go ahead and get started. So if everybody's got something to drink, my name's Phil, and I don't know whether you're going to learn anything, but you won't fall asleep, okay? We have a tradition at KNIME that we started back in 2012. And the tradition is this. We are trying to take hot topics that really haven't been done before and use KNIME to do something cool. And how many of you are here for the first time? Yeah, a lot of you? Okay, so let me just give you a 1-minute summary of what we've done, because there are some fantastic people at KNIME, and they've been pulling together techniques and data. You're going to ask what I'm responsible for? I'm responsible for the music. And so what we've done since 2012 is we have tried to pull together data, techniques, things that haven't been done before, and music. So a 1-minute summary. Everything I show you is available as examples and as white papers. In 2012, we had a lot of fun. We combined text mining with networking, kind of a dueling banjos sort of thing. Then we had a lot of fun. We did time series analysis, and we combined it with machine learning. And normally they're two different fields, and we pulled them together. It's a lot of fun. This was great. Thanks to the US government, who gives data on everything, we did an IoT project on bicycles. Last year, this was all about machine learning. This was all about maintenance prediction. We took some fantastic data, combined it with imaging and music to do some cool things. Last year, I'm 1 year out, guided analytics. Do you know we are in the sexiest job of the century? Isn't that cool? The music was appropriate. But as you've seen at the conference, every single one of these topics we've carried on. So we had a problem. What was I going to use this year, and what music? This project started last November. We were at a Predictive Analytics World Conference, and we were asked to talk about models and model management. And I presented some theoretical ideas in KNIME that got quite a bit of excitement. Now, is Dean here? Dean, this is all your fault, because he got really excited, and he came up and he said, "Oh my God, Phil, I want to work with you guys. This is so cool. This is next generation." And I remember that word, next generation, and it got me thinking about what it is we're doing. And, you know, when you start talking next generation, I'd like to just give you a little story, because if you think about it, data is a frontier. And if you think about it, KNIME is on a mission with you, our users, to explore new data, blend new techniques, create new ideas, and bring data science to new groups who haven't had that up until now. Our mission is to go quite far. As a matter of fact, we are boldly going to go where no proprietary will ever go to deliver you data science. Next generation. Oh, yes. Is this cool? Okay, guys. I wanted to do that for years. I hope Michael doesn't fire me now, but he does allow me to have 5 minutes of fun. This is really exciting. So really what happened is, now I'm wearing burgundy, and burgundy is command. Notice that I don't have any little KNIME things. The man with all the KNIME things on his collar is back in the back. That's Michael. And when we started talking about this idea, he took the KNIME team, he sent them up to a mountain and said, make it so. You're going to see the results of that right now. And what I'd like to do is I'd like to bring Iris up on stage with me, and we're going to do this together. Iris, come on up. Is this cool? Now, everybody knows what blue means on Star Trek, right? Blue is science. She's the scientist. I'm the guy with the music, so just as long as we get the things going here. Now, what we're going to do is we're going to go back and forth. We're going to try to give you some ideas. Before we dive in, I'd like to show you and position everything for just a minute. I'll do this very quickly. How many of you have heard of CRISP? Yeah, everybody? So the documented way of defining data science. There used to be 3. I wrote the second one, and I must admit, the third one is better. And there's the diagram. So I'm going to use that as a basis for this presentation. I'm going to talk in the abstract, and in a moment, I'll hand over to Iris, who's going to make it reality for us. If you'll bear with me, that diagram can be translated into a nice bar at the bottom. Everybody okay there? You're with me? Okay, when we start talking about modeling and model factor, it's one of those buzzwords that everybody's they're just ranting and raving. One of the biggest manufacturers of analytic software out there labels Model Factory for an application that pulls together 7 products that don't work together. You know, I believe in marketing, but that's a little much. There's got to be something more behind this concept of model management in a model factory. Another very hot topic, and as a matter of fact, this is a real example. Iris and Rosaria and I worked on this a little while ago, and this is really cool. This is lots of different models, and it automatically decides which one is right. Really cool stuff. It's a bag of models, though. It's not model management. Very important. KNIME does it really well, but it's not that, because it's just that little bit in the middle. There is a third one out there, and this is actually starting to do it right. It's Dynamine by Dymetrics. They're here at the conference. It runs on top of KNIME, and it basically requires a specific analytic data mart underneath it. But as I got into this a little more, I started looking at the concept of a modeling process. This at the top is a process, and we've all seen this sort of thing. If you don't know what this is, you're in the wrong conference. Yeah? Very, very simple example of a KNIME workflow that does every single one of these. And we all know that we can make these as complex and robust as we want, and we've seen lots of examples of that today. I love some of the things I saw from Eli Lilly. So we know we can do this. Now the challenge when you move this to production is the following. Many times, we create a great model, we want to move it in production, we manually test it, and then we go and we push it. And we go back and forth, and we kind of need to check it every once in a while. Well, we can do something there too, because if you think of it, a model over time is going to fade. It needs to be retrained. You can manually do that, which is quite tedious. But of course, you can do that in an automated way with KNIME as well. So yeah, we've got all the components for a complete model management process. But there's something else that KNIME has that no other package has. And this is the key to our model factory. It's the fact that everything in KNIME, it's not a scripting language, and what's happening behind the scenes, it's all metadata. Every single thing that you click, that you define when you do configuration, it's all there. And all of the things you would want to know are actually available for your use via flow variables and things like that. So what does this mean? Well, the first thing it means is that we think of the model process, not the model. The model is very important. It's just another kind of data. And by the way, it can also be described as metadata. So you can sort of see where we're going here. We're going to take the entire model management process and put it into a KNIME workflow. And that's why I need Iris, because I just come up with the ideas, and then she works with people to make it happen. Before I hand over to Iris, let me just give you one or two little things that will help. There's some new terminology we've used, and Dean, we've tightened this up a lot since you and I first talked about it. The first one is, so the top blank, that's an abstract modeling process, okay? And it has to be filled with something, and we filled it with process steps. And what are those process steps? They are actually little KNIME workflows. That's all they are. So we're back in the land of KNIME. And we're just making it really easy to build them. We still are creating models. That's a special data type that we can then save and use and deploy and do lots of things with. But it's all about that process. Are you with me so far? Two more things that are really important before I shut up and hand over to Iris. The first one is this. What do you do to go from the abstract concept to a practical? We call that a process definition. And that is defining 7 little pieces of workflow that would go together to define a complete process. Now, since it's KNIME, you're going to see that a lot of them we can reuse. Maybe you don't have to write ones every time. Once you write it once, maybe you can use it for different things. But you might have one for a process to do customer segmentation. You might have one process to do maintenance prediction. You might have one process to do churn prediction. And those are the workflows. But we're still not pointing it at data. That comes in the second step. The model process configuration. The model process configuration is where we take the different processes, you can see them at the top, and we instantiate them. And we say, okay, process 1, I'm going to point at product 1. I'm going to use process 1 again and point it at another product. I'm going to use process 1 again and point it at a third product. Here, I've got it for my 4th topic, and it's on and on and on. So what we've done is we're defining little reusable process steps that are KNIME workflows. We're defining them in 2 structures, process definition and model process, and then we're using them to automate. Any questions so far? I think everybody gets it, right? So now the trick is, how do you go from this vision to reality? And I'll turn it over.
Thank you, Phil.
To Iris.
So, thank you for the introduction. I now will try to tell you a little bit more about the technical details, how we implemented all of these. You here see the 2 key parts. The one is our real model process factory. This is the one on top where you're seeing the full workflow. And the lower one are the 4 data tables, or as Phil would call it, our metadata, which we are using to describe all of the processes, the modeling configurations, and the results of the 2 of them. I would like to start with the first table, which is the model process table. As Phil already said, the model process table defines the processes. Each of these processes consists of 7 different steps. This is how such a table can look like. I will get to the data we are using in the example a little bit later. But what is important for now is, when I'm building my first process name, which is called Airbnb rent app prediction, I defined 6 processes in total. The deploy process, for example, is optional here, so I can just leave it out. If I now want to make another process, for example, the Airbnb prediction cities, I can just reuse I reuse 4 steps, and I will only redo the other 2. So I first have to have built my 7 steps for the rental app prediction. Afterwards, I need to decide which of them I will reuse for the prediction of cities. And I first will make an init step, which is going to load the data and initialize parameters. This I have to do new. Then I also have to make a new load steps. This you can find here. It's also specifically made only for the Airbnb cities prediction. But the last 4 steps I just took from above. So I reused these 4 steps, and you might remember the steps are underlying workflows. And this is how such a model process table in the end looks. The second table we are using is the model configuration table. We now need to tell the factory how each of these processes is supposed to be used. And this is done in the model configuration table. In the model configuration table, I have as a first parameter a model name. For example, if you're going back to an Airbnb, such a model name can be Hong Kong or can be Venice or Vancouver. I afterwards have to define which process I'm using for this specific model name, and the process and the model name together then build my unique identifier, which defines the model configuration table. Afterwards, I have a metric, which is the evaluation metric of this process. Then I have a threshold, which we are using to define if we are going...
I'll help.
Phil is helping. And this is a threshold which we are deciding if we have to relearn a model or not. Then we have the current model, which is empty here because it's the initialization of the model factory. This is why we have all missing values. Afterwards, we have an update type. The update type you can use to define if you currently want to update your model or if you only want to do the evaluation. Next to the update type, we have a model initialization. This model initialization parameter is good if you don't have enough data to build your specific model, then you can use the data of another model.
This is really cool. Really cool.
And
I just had to say that.
And up next, we have the challenger model. This is a process we are comparing to the current model in case some young person come up with a better model and we want to compare it. The last 2 parameters are clear. We have a person responsible for it who might get the reports as soon as we are updating our model, and we have the last execution time. These are the 2 tables I already described to you, the model definition, as process definition and modeling configuration. And the last 2 in line are then automatically filled by the model factory itself. We have 1 table, which are the models, where we are saving all of our past models. And we have 1 evaluation table, where we are saving the last evaluation values for each model name, process name combination. It also might be important to know that we always have these date model created parameter, because by this identifier, we are configuring the models to recognize when we've learned them and directly have an identifier for them. This is how the model factory looked in a very, very abstract way. You remember I already told about the modeling configurations. Those are loaded in the very first step of my workflow. I will also directly filter those which are not needed because their update type is currently missing or is set to not executing. And then I'm going into the loop and repeat for all the modeling configuration my abstract model factory. In addition, I also have to here up in the end some clean up and collect. I'm here deleting some temporary tables. We already said this is just a brief overview of the model factory. The full details we will release on Friday. And this we are repeating until all of the models are even learned or not relearned based on what we've evaluated. This is one part of the model factory. This is the other one. And this is actually the more important one. So this is the inside of the model factory. We are now repeating this for each of our modeling configurations. And we are now repeating the 7 steps. The first step is the init step. where we are initializing parameters for the rest of the other 6 steps. Let's take a look into the init step. This is how such an init steps looks like. The init steps basically here in front need some pre-processing, and then we are going directly to the call workflow node. The call workflow node is our heart of the complete model factory. You cannot run this complete factory without the call local workflow node, because it's always calling out to these other workflows, which are our small process steps. Such a process steps, and here's how we are talking. The interface between the different process steps are all regulated via JSONs. The init step, for example, which you are looking at here, gets a JSON input file which contains all parameters of my modeling configuration. And in the JSON, in this input workflow, I can then decide which parameters my load workflow, our next step, will need. And this is done in a template like this. This is the init templates. We are also going to release these, so you can just edit our templates to have a fully running model factory. You here see that we are starting with a JSON input and then a JSON to table. This transforms the whole input into a data table, which can be reused afterwards. And how you would now use this, for example, you could use this init workflow to output a name of a file you want to read. You could point to a file somewhere in the cloud, you can point to a local file, but you can also only return a filter criteria for the next step. Basically, you have all possibilities you want to achieve.
I wanted to call all of these sections because you're going to see, if you come on Friday, the structure is exactly the same. Iris put a really good name here. She said, your custom code. I wanted to put your cool KNIME stuff, but she didn't like that. So basically, you leave the top and you put your cool KNIME stuff down here. 1 or 2 rules to follow to make sure they all work together, but basically, all of the stuff you've been doing, you can put right in here and make it as simple or as sophisticated as you need.
So let's go back to the full model factory so you have a feeling how this is working. We already did take a look in the init. The init is the one initializing parameters. Afterwards, we are calling the load step for loading data. Then we are, after the load step, going to transform the data. The task of the transform step is that you do maybe some pre-processing, and in addition, you need to split the data into a training and a test set. You can, for example, just leave out the training set. And if you don't return a training set, you cannot do a training, and in this case, we are using the model initialization. After we did the transformation, we are going to this case switch, and based on what the current input is, so if we have a current model, we can directly go to the top where we are selecting the current model. If we don't have a current model, but we have an init model, we are selecting the second pass. And if we currently have data, but we don't have a model which we can evaluate, we are going to the third pass. Only in the above 2 paths where we already have a model for scoring, we are going then to call out for the evaluate step and the scores cap. We are finally combining all of this with the second end-if node. And in the next if-end combination, we are checking if we now have to do a retraining of the model or not. And in case we are having to do a retraining, we are going to the upper part, train the model, and then call out for the deploy workflow. The deploy workflow, for example, could push your learned model into some cloud for later scoring. You could translate it into a jar file. There are tons of options. This is how the complete abstract model factory now looks like. So you see I first discussed the lower loop and then the factory itself on top. We were using 2 use cases, which we will discuss in a little bit more detail on Friday, but I shortly wanted to mention how this can look like. Our 2 use cases were, at first we had some product data, more precisely it were TVs and washing machines, and we wanted to predict the price of the 2 of them. But we decided here to only predict if the price is going up, down, or if it's currently stable. The second example we are using, you might have already seen, this was data from Airbnb, where we had the prices from the apartment, and we also did know how many apartments were currently filled. And there we did some price prediction, and we also did a prediction of how many apartments in which city are currently rented out. These are our results for the Airbnb prediction. You see in the plot on the left, the green dots tell you that we could just use the evaluation model or the model from past. And the red dots on top tell you that here the error exceeded some threshold and we had to do a retraining. Here I was always using a root mean square deviation between the prediction of the model and the original price. For the product data, I did a little bit something different, because here we only wanted to compare if we still have an upwards, downwards, or stable price trend. And I compared the two of them by saying the difference between the two of them is 0 if they are equal and 1 otherwise. So the one on top, which is the TV number 127, had to be retrained 3 times, while this washing machine below here only had to be retrained once in total.
Okay, this is going to be fun, because the way we put this together is I came up with use cases. I came up with as many use cases as possible. And I thought, okay, let's document the use case. And what we're going to do is we're just going to walk through 3. So if you love code and love workflows, then the last 5 or 6 slides were good for you. If you'd rather have business cases, the next 3 slides are for you, because I did those. So Iris, what I want to do is I want to model a process, but I want to do it on different products. And so I think it's the same thing, but I want to do it on hundreds or thousands. How do I do that?
Yes, Phil, you can do this. We will not do this every time.
Yeah.
So the trick here is that you only need to define the init workflow, and the init workflow gets the parameters from the outside. So if you are changing your model name, you can easily generate hundreds and thousands of models just by manipulating the model configuration table.
Okay. So that one's really good. That's already really quite powerful. Okay, what's the next one? I've got a model that it's being scored and we're collecting statistics, but I don't want it rescored automatically. I want control about what happens. How do we do that?
So this is the update type you're searching for. We have 4 different update types. The update type can be missing, then we are ignoring the modeling configuration in total. You can set it to automatic, then the whole model factory will run every time. But we also have manual, then only the evaluation will be done, but never the deployment and the training. And we have manual retrain, and in case of a manual retrain, it's going to be exactly trained once and deployed once, and afterwards we are setting the status back to manual, so it's not going to be retrained a second time.
So it'd be good for me if I have lots of automatic ones, but if I want to keep a complete view of all of my model processes, even if I only need to retrain it once a month, once a year, when my boss gets mad, whatever, then I just set model retrain, yes, and I can do it in the same infrastructure. Okay, what's the next one? Oh, this is one that was really tricky, and it was actually one that comes up quite often. A lot of times in a production situation, I don't have enough data for a model. Yeah? And so I have to produce a model because there's a production system that will fall over if a model isn't there. But let's say on the price prediction, it's a new product. I only have 1 day's worth of data. I can't generate a model from that. So how do we handle that?
You can handle this using the model initialization. This will just use the model from another modeling configuration which needs to have the same process assigned. And for example, Phil suggested here, we could just do this using a similarity search based on the name, which would work pretty nice on our example where we had these products, because for the products we had names like CSTV 0049, CSTV 0127, and something like this. Then we could just use the nearest neighbor of the product.
So what else did we have? classic in campaign management, I mean, I work on customer data, so classic in campaign management is I have an existing production model. It is what I would call my champion model, but I have some bright, smart data scientist who thinks she can do it even better, and she wants to create a model process and actually challenge it. How would we handle that in the model factory?
I would just add another model process and another model configuration. I would set them to the same model name so we can compare the two of them. And then, very important, I would here set the update type to challenger, so I will never have to deploy this model. Because this would be a model I don't want to deploy, I only want to evaluate and retrain it over time.
So I could have a champion and a challenger model running at the same time, collecting all the information, but the challenger wouldn't be pushed to production until I decided to.
Then you set it to manual retrain.
Right. Excellent. This is an interesting one. I've defined the 7 steps, and I understand them, Iris, but sometimes I don't need all 7 steps. Is it going to break? What do I do?
So if you don't need any of the steps in my templates I made, I already added comments how you can skip the steps. For example, the deploy steps, this one is a little bit special. You can just leave it out, and we will handle this. And for all of these others, I've made you default steps, which will just push the data through and doesn't do anything else.
Okay, what do we have next? Yeah, and this was one. I know, Dean, this was one that was interesting for you because we said, okay, well, we've got the basic definition, but we've got security standards. I mean, I assume, who was the guys that were asking all the questions about it? You know, we have security standards. How do we manage some of that? What can we do, et cetera, et cetera. The point of all of this is, of course, we can extend every single table. The tables by default are in KNIME tables, but we can swap those out, and you can have those tables in anything you want. So that's how we do this one. And I had to talk on this one because I think this is cool. We've got it to the core to make it all work. And Iris has made sure in everything that you can extend this with any fields you want in any way. So that is really cool. My compliments. Right.
Thank you. This was, we also wanted to talk how you can actually use this. The examples we just showed you are already on our example server. And the full model factory is completely usable within the KNIME Analytics platform. The only thing you need is the personal productivity license, but we mentioned early this morning you can get it by buying it for €0 from the store right now, and we will make the code and everything open source and free as well pretty soon. Okay. So if you're now in the KNIME Analytics platform and you need to edit those tables, it's a little bit difficult, but you can easily make it by defining, for example, such a row splitter, splits the data into 2, then just manipulating the steps you want to. For example, here, I selected some of my modeling configuration, replaced them with the Airbnb price prediction cities. This is now going to be my new challenger model. And then I concatenated the 2 tables together and have everything saved again in my modeling configuration table.
The big purpose of having it on the desktop is so that you can play, you can learn, you can extend. We've got some examples with it. And it's not how you would want to do it in production, obviously, but we wanted to make sure that with our open source philosophy, every single person here could walk away and download this and use it on their desktop, and that's what we could do. Now, I think the next slide has to do with the server. And I'm going to hand over to Iris for a minute to walk you through just a really, really quick example. But of course the real power of the model factory comes when you can combine it with the KNIME server and everything we heard this morning and everything we had this afternoon, because then we have the ability to update and maintain over the web portal. We have all of those features we were talking about earlier when it came to, you know, scheduling, status control, check-in, check-out, versioning, security, all of the other things that are there. So the exact same KNIME Model Process Factory that we have that you can use on your desktop to play with and learn is the exact same thing that you can also load into the KNIME server. And we're going to just walk through a real brief example. We're going to try it as quick as possible. Everybody can have these slides, but we just wanted to show you how nice this is when you're doing it over the web.
Okay, this is just about scheduling. I'm not going to spend too much detail in, but the full theory, of course, assumes that you are re-executing this model factory daily or hourly, depends on how often you want to have this. And this you can do on the KNIME server with the KNIME server execution, scheduled execution. Now, how can I edit my tables? And how can I do everything if I'm not an expert user? And this you can do using the KNIME web portal. I will do it the full way and just log in.
Oh, touche.
Touché. Now, let's just take a look. So we have this model factory, and if I now want to write it, I'm going to select the model factory from my KNIME repository. I will have to click Start to start the model factory. And then if I'm going to the web portal administration guide, you can actually see that that the model factory is just running. You see that it's happily running. It currently doesn't have an output produced because it's not finished. If I now want to make any changes, I'm going back to the web portal, and for example, I would like to update my type. Then I will start this workflow. I'm going to select, oh, I'm sorry, I'm in the wrong. This is the web portal update where I want to add a new process. So I'm going to the web portal, select the web portal update workflow, select the add a new process, and then on the next page, I can on top define the process name, and below I can select one workflow for each of my steps. It's a little bit longer, here's the init and the load, and the rest of it is below. And if I go next, the workflow executed successfully, and I've generated a new process. What I also can do, if I now execute the web portal update type change, I can change any of my modeling configurations to a new update type. For example, in this here, I wanted to change the Airbnb rental app prediction to a manual process, so it's going to be no longer be retrained. And just going next, and we updated 2 of these modeling configurations. And then after I did this, my model factory was executed successfully.
Okay, what's interesting about this is we've kept these examples very simple. Everything is available. Who's on a laptop now? Who's got KNIME open right now? Anybody got it open right now? If you go to the public examples and click on it, you will find there's a new category as of this morning called Model Process Management. And in that Model Process Management is everything you've seen us presenting here. So unlike years in the past where we gave you some ideas and then it took us sometimes a little while to get the white paper, since our commander said, make it so, we have not only all the workflows, but a 40-something page user guide. It's also on the web right now, and you can download and start using it between now and the next and Friday. We've got 1 or 2 things that we've got to sort of wrap up here. How far did we take this? Remember when Iris showed you the call local workflow, and she said that's the heart? It really is. Because once you understand how this works, you can start using all of the rest of the things in KNIME, either from within the local workflows themselves or in the factory. So you decide you need to do some Spark, fine. You decide you need to do some of the other things, fine. All of the capabilities you have for deciding where KNIME should be executing, what KNIME should actually be calling, are still all available to you. This is pretty cool. But what we've done is we've kept this down at the basic core level so that you can learn the concepts and play with it. And I guess that's pretty much it. Was that interesting? Because before you go off of stage, when you're wearing something like this, there's only one way to end. Is the music on?
No.
Should be the music. Well, I'm going to go make the music go.
I'm not allowed to do anything with the music.
So thank you very much. If you liked it, clap for Iris. She did all the work. And